Okay, this is just to give an idea of what might be available here in terms of aircraft with roughly perpendicular to the interstation path crossings. I got my aircraft scatter program here, and this is me down here in FN20, America Golf, and up here this is close to where Peter VA3 ELE is, near Toronto in Canada. And we're running live here. That's not what I want to do, actually. I want to show you what's available for analysis in terms of the database. A few weeks ago, the weekend of April 24th, I just ran the program over the weekend to accumulate planes and basically what you can see on the screen here for that weekend period to see what was available. And we'll just click SQLite database here to go to the database. And you can see if you zoom in that showed there were about 268,000 hits. In other words, 268,000 bits of data from ADS-B or MODES transponders from aircraft during just that weekend. Um, and that's what I want to do now is reduce that to just aircraft that are close to the path here. I'm going to do a 50-kilometer radius from each point on the interstation line there by doing Control Delete down here, then a Control Insert up there, and we'll click over here on the query form. It says select aircraft on a great circle path between the 2 points. Then I'm going to order the results by radar cross section, date and time, and we'll just hit query up here. It automatically generates the query, and that narrows it down from about 268,000 hits to 37,000 hits roughly. Um, we're still seeing live planes here. I'm going to click here, show planes from database, and we'll switch over here. And here you can see this is now the first, this will be in series of 200 planes at a time from the database, except that uh, what we're going to be doing is excluding planes whose uh, radar cross section is below a certain value or um, who are below a certain elevation at the two ends. And right now I've got it set up. You can probably see down here. I've got the minimum elevation set to zero, minimum rather altitude set to zero because the altitude doesn't matter when we're uh, putting the restriction on the elevation of the planes as seen from the two ends of the path. Also got a minimum radar cross section of 10 set in, and I put the elevations at both locations to 0, which is pretty close to the um, general uh, horizon at both locations. But mine's actually a little bit worse in directions towards Peter, so I'm going to change it to from 0 to 0.1 degrees by just doing a Control Z here. And I'll type in 0.1. We'll just tab through that. We change that a bit. You see, it really didn't make much of a difference there. Now, if I had instead gone and change that to 5 degrees, obviously you would expect that to make a huge difference. And as we cycle through here, see that takes out all the planes except for one. Uh, and there's one plane very close to me that stayed in there, but let's put that back to where it belongs. Minimum altitude 0.1 and 0 for Peter. Click enter there, and then I have to go forward and back and that brings everybody back. You can see here there are a number of planes that look like they're nearly perpendicular. Here's one there, there's one there, and these are now all planes that are visible at both ends. As I cycle through here, 200 planes at a time. These red planes, by the way, are all red means the radar cross section is greater than 50, so those are large planes. For comparison, a 747 would be about 63, 64. So we're going through here. We've got quite a few planes with perpendicular cross sections, as you can see. Now we're getting into the black planes are between 30 and 50 meters squared for their radar cross section, getting into the smaller planes. And we've looked at about 800 planes so far. Not 800 planes, but 800 bits of transponder data. And it turns out that for each flight number over the weekend, I got an average of 31 hits. Now, the same flight number may have been repeated several times as it flew back and forth, but that gives you an idea of things. And here we're now into the solidly into the 30 to 50 RCS plane category. You can see we've got again some nearly perpendicular cross sections, some that aren't quite as perpendicular. Now the brown planes are 10 to 30 meters squared estimated radar cross section. We won't even look at the tiny ones, the blue ones below 10, because they probably wouldn't be very helpful. So we'll just cycle through here. And again, well, it would be 200 planes at a time if we were showing everything. We're just showing what's along the path and limited to radar cross section greater than 10 and elevation greater than 0 at both ends. Continuing to cycle through here, and that's there we ran out. That was 7,800 bits of data, 7,800 bits of transponder data before we ran out of planes that fit the criteria. So it looks like there'd be a number of opportunities over the weekend. I went through and counted up all the planes that had radar cross section of greater than 30 that looked like they would be pretty perpendicular and good for attempted ACUSO. And there were 18 of those. So the next thing I'll have to do is go through the data and check the times, see if they're at reasonable times for Peter and me to make the attempts. Or maybe, it might be that a lot of them are UPS and FedEx planes that are flying around at 3, 4 a.m., which might be less attractive for both of us. So that's just an example of what's potentially available. We'll just go back to the beginning there and end the video.